Now, as we talk about the structure of an atom, you're probably going to want to take out your periodic table because we're going to refer back to the periodic table. It'd be nice to have one of those guys handy. The structure of an atom. We stated earlier that an atom is the smallest particle of an element that retains the chemical properties of that particular element. Right here I have listed some different elements, some different atoms: hydrogen, helium, lithium, carbon, nitrogen, oxygen. And if you look, we got a name, we got a number, we got a symbol, and we got another number. Okay, this is one of the simplest periodic table of elements because it only has those four things: a name, a symbol, and two numbers. Now, if you look at your periodic table, it has a lot more information than just those four things. But we're going to discuss these four things here today. So, our objective today is to understand those four things that are listed right here on this simplified periodic table. Now, are these four things on your periodic table? Absolutely. The top number is the blue number on the upper left, right? And the bottom number is the red number on the upper right, correct? All right, so these numbers are on your periodic table. Now, we've talked about this also, folks. I don't know if it's important for you to regurgitate this again in your notes. For those of you that have to write down everything on every slide, it probably is important to you. But you're probably not going to have time to write down everything because I'm going to move through it fast. Okay? We know that the atom consists of two regions: a nucleus that has positively charged protons, negatively charged neutrons. Now, let's go back. Remember, we just learned it. Who founded the nucleus? Who discovered the nucleus? Who? Ernest Rutherford, and he did so on what experiment? The gold foil experiment. There's an area surrounding the nucleus that is occupied with negatively charged particles that we call electrons. Who discovered the electron? J.J. Thomson. Okay, J.J. Thomson. And then if you remember, Bohr stated that these electrons are orbiting the nucleus. So these are combinations right here of all three of those gentlemen with the atomic theory. So we have a nucleus, we have an area surrounding the nucleus that has negatively charged electrons. Here's a diagram of this. When I had the notes before, I had another slide that I didn't click on that had Bohr's planetary model. But on Bohr's planetary model, these blue and red spheres here would represent the nucleus, and these little circular orbits around the nucleus is where the electrons follow or orbit the nucleus. So in this model, we've got electrons orbiting the nucleus, we've got the blue spheres which represent neutrons, and the red ones that represent protons. Now, if you would look at this, for this specific element right here, there are 3 protons, aren't there? How many neutrons are there? 4. Okay. If you would add them together, what total is in the nucleus? 7. That's very good math, folks. Good job. Okay. So remember that. The atomic number, which we represent with the letter Z. The atomic number of an element is the number of protons in the nucleus of each atom of that element. So if we go back to the diagram that I just showed you, okay, the atomic number is the number of protons. So when I come back here, how many protons do I have here? 3 protons, right? Look on your periodic table. Find where the atomic number is located. What is the atomic number on your periodic table? The blue number, where is it located? Top left. What element has 3 protons? Lithium. So right here, this diagram up here is lithium. Now, does it matter how many neutrons are there? No. If it has 3 protons, it would be lithium. What if I would have an element that was added 1 more proton? Would that be lithium? No. That would be what? Beryllium. So, the atomic number is the number of protons. The mass number, which we represent with A. The mass number we represent with the letter A is the total number of protons and neutrons in the nucleus of an isotope. You don't know what an isotope is yet. You will in about 10 to 15 minutes. All right? So the mass number A is the total number of protons and neutrons. Well, let's go back here. Let's go back here again. I'm going to show you one way that we write these things. We take the symbol, and I'm just going to put SY, meaning the symbol. What was our abbreviation? What letter did we use for the mass number? A. So if I have the symbol, the top number is A, the mass number. What did we use for the atomic number? Z. The bottom number is the atomic number, Z. Let me get a little bit better of a Z. Whoa. Let me get a little bit better of a Z. So, if I'm going to use this notation right here, okay, we already said that we know what element that is because of Y. How do we know what element that is? Brooke? How many protons? And the protons were 3. So that means the element is lithium. So my symbol is Li, lithium. My Z is 3 because I know that lithium has 3 3 protons. Now, what is A? What is A? 7, Ethan says. How'd you get that? the neutrons and the protons. Right here, when I add those up, 1, 2, 3, 4, 5, 6, 7. So when I use this notation, the 7/3, lithium, I know that there are 7 protons and neutrons. 3 of those are protons, so how many neutrons? 4. That's a little better math. 4. Now, I'm going to put another one up here just to show you. Here's another one. Obviously, I'm dealing with carbon, right? Look on your periodic table. What's the atomic number of carbon? 6. So that means I have 6 protons, right? How many neutrons do I have? How many? 6. All right. So I have 12 for my atomic mass, and I have 6 for my atomic number, right? Now, here is yet another one. Have you ever heard of carbon-14? Okay? Carbon-14. That is carbon-14 right there. What is the difference between carbon-12 and carbon-14? You tell me. Parker? Carbon-14 has 2 more neutrons. It has 6 protons and 8 neutrons. Now you're going to see that number that Kane was spitting out before, 12.001. Find that on your periodic table. The red number, right? That is the average of the isotopes. Okay, that is the average of the isotopes. So, if you're going to tell me which one is the most common, what do you think it'd be? Which is the most common form of carbon? Carbon-12 or carbon-14? Carbon-12, because that number there is closer to 12 than it is to 14, right? So the more common one is going to be carbon-12. But that's what that number is there that you got built in. We did atomic number slide. We've done mass number slide. Let's look at this right here. Okay? Here's just another version that we can use. Now, I look at this and I say, okay, my atomic mass is 10.81. Atomic number is 5. I know it's boron because boron has 5 protons, right? So, if I'm going to look at this, I'm going to say my mass number rounds to 11. My atomic number is 5, meaning that there's 5 protons. 11 minus 5 will give me 6 what? 6 neutrons. All right? 6 neutrons. Not too tough, is it? Now, I told you were going to learn about isotopes, and here you go. Here you go. It states here that all hydrogen atoms contain only 1 proton. How many hydrogen atoms have 2 protons? None, because if you have 2 protons, you are helium. Okay? So all hydrogen atoms contain 1 proton. However, hydrogen atoms can have different amounts of neutrons. Number one here, protium. We're going to talk about three different types. Number one here, protium. The nucleus contains one proton only. It does not have any neutrons. Protium has one proton only, and it has an electron moving about it. One electron orbiting one proton. Protium makes up 99.985% of the hydrogen ions that are on Earth. So the majority of hydrogen ions on Earth are protium. However, we also have a substance that's called deuterium. Deuterium consists of one proton and one neutron. Deuterium accounts for approximately 0.015%. Okay? 0.015% of the hydrogen atoms found on Earth. So deuterium is one proton, one neutron. The third one I'm going to talk about is tritium. Tritium contains one proton and two neutrons. One proton, two neutrons. Tritium is a radioactive element. So tritium is radioactive. So these three are all isotopes of hydrogen. So if you were to give me a definition for an isotope, you would say it's what? Okay? It's what? John, give it to me nice and loud. What do you think? I couldn't hear you. I'm getting old. My ears are bad. Different versions of the same element. How do they differ, though? The number of neutrons. They have the same number of protons. The number of neutrons differ. So, when I pop up this next screen, I'm going to teach you a new way of showing these, and it's what we call the hyphen name, the hyphen method of naming. The hyphen method of naming. Here are the three hydrogens. Hydrogen, go back. Hydrogen 1, hydrogen 2, hydrogen 3. Now looking at this hyphen method here, hydrogen 1, hydrogen 2, hydrogen 3. What is the 1, the 2, and the 3? What's the 1, the 2, and the 3? What do we call that? Huh? They are isotopes, but what's that number? Look back in your notes. That is the same thing as A, which is the mass number, which is equal to what? Protons and neutrons. So if I'm looking right here, here is hydrogen 1 over 1. That means that the number of protons plus neutrons is 1, and the number of protons is 1. So how many neutrons are there in protium? 0. Let's go to deuterium here. Hydrogen 2. 2 over 1. That tells me that there are a mass number of 2. 1 proton. How many neutrons? 1. Let's go to tritium. 3 over 1. How many neutrons in tritium? 2. How many protons? 1 for a total of 3, right? Those are isotopes, people. Same number of protons, different number of neutrons. Now, this last slide I'm going to show you here is just reinforcing what you just did. Here is boron 10. Okay, don't look at anything right there but boron 10. Find boron on your periodic table. How many protons does boron have? Boron has 5 protons. So boron 10 has how many neutrons? 5. Boron 11 on the right-hand side there. How many protons does boron 11 have? 5. How many neutrons does boron 11 have? 6. Okay? So right here are 2 boron isotopes. Now look at your periodic table. What is the atomic mass on your periodic table? The atomic weight of boron. Okay? It is 10.811, right? Which rounds to 11, so the most common isotope of boron is going to be what? Boron 11. Okay?